Welcome, Algebra 2. This lesson is 4-8, Complex Numbers. Essential question, what is I? Let's begin. This is I. This is the imaginary unit. So we label this I. It's one of those special characters, kind of like pi represents a number 3.14 and change, and there's number E that's 2.7 and change. Well, I is another special number, and I has a very special meaning. I equals the square root of a -1. Which we used to tell you that you can't do that and it's not real. Well, it isn't real. It's imaginary. So two things you gotta know. I squared equals -1, or I equals -1, and therefore I squared equals -1, which is weird because usually when you square a number, it's positive. But in the case of I, which is imaginary unit, it equals a -1. So you need to know those things. And we can do some neat properties with these. So some of the general rules for I: square root of a negative number, you can break that up into square root of square root of -1 times that number. So basically I reduces to I times the square root of the positive version. So in this example, square root of 49 would equal 7, but square root of -49 is going to break up into square root of -1 times square root of 49, which is going to be I times square root of 7. Notice we put that I before the square root. The reason we don't do square root of 7 times I is sometimes you might write this too long and it looks like your i's underneath that. So just get in the habit of writing the I first, then the square root. Square root should be at the end. Alright, so neat properties with I. What if we want to figure out I to the n power, where n is any number? So we can go down this chart. Well, I to the 1 power is just I, and I squared is -1 because we told you that. I cubed is actually going to be -I. I to the 4th is going to be +1. I to the 5th is I. And you start seeing this pattern develop here. Well, and this is going to be +1. What's that pattern? You see something repeating, and it's every four digits or answers is repeating, and it keeps repeating on this loop. So there's a pattern here, and we can use that to figure out any I to any power. The way you do this is you must take that power and divide it by 4. So n divided by 4, and whatever that n is, and then the remainder, it tells you what it reduces to. So if the remainder is 0, your answer is 1. If the remainder is 1, it's I, 2 is -1, and 3 is -I. So let's do some examples of this. So I to the 23rd power, to figure out what that reduces to, you divide 23 by 4. And if you do that, you get 5. And you get a remainder of 3. Since my remainder is 3, when I have a remainder of 3, it reduces to -I. So I to the 23rd is -I. Forgot to mention this modulo. That's the kind of term of that. If you've done maybe sometimes computer science, you've heard of that. It just takes a number and just leaves the remainder. I to the 100th power is going to be 400 divided by 4, and that goes in 20 times, 25 times, with no remainder. So it has a remainder of 0. Since the remainder is 0, I to the 100th reduces to 1. For I to the 46, you divide that by 4. That goes in 1 time. 0, drop down to 6, goes in 1 time, and then you're left with 2. So your remainder is 2 in that case. I to the 46 is going to equal -1. So that's how you do it. Divided by 4, follow this table. Alright. Another thing with imaginary numbers is imaginary numbers have a real and imaginary part. So this is what we call this. A plus BI is usually the formula you'll see. And the real part is the A part, because it's just a number. The imaginary part is the BI, because it has the I attached to it. So the real part and imaginary part. And notice B can't equal to 0. Now you hear me use this term complex numbers and imaginary numbers, and usually I use them both. The idea here is a complex number, it's the same as imaginary, but B could equal 0. So technically a real number like 5 could be complex, but 5 can't be imaginary. And 5 plus 2i could be a complex number because it has the I part, and it could also be an imaginary number. So it's just kind of like that rule with like saying whole numbers and natural numbers. One has 0 and one doesn't include 0. Complex and imaginary is kind of that same deal. So I might use those interchangeably. Let's talk about adding and subtracting complex numbers. You treat the I like a variable. So just like if it was an x. So it's like 4 minus 3i plus -4 plus 3i. Treat the I as an x. So combining like terms here, combine the 4 and the -4 are going to combine to 0. And then -3i and +3i are going to combine to 0i. So it's 0 plus 0i, which is just 0. It's kind of a terrible example. Let's do another one right here. Hopefully this is better. This negative I'm going to distribute to both terms, the real and the imaginary part. So this becomes plus 2 minus 4i, and it's 5 minus 3i. And we combine like terms over here. So combining the real numbers, 5 plus 2 is going to be 7. And then negative 3i and negative 4i combine to negative 7i. So the simplified form is 7 minus 7i. That's what you combine them to. You can also multiply complex numbers. And you treat the I like a variable again. But in the case where you have I squareds, you actually substitute those to negative 1. Because I squared, like we said in the earlier slide, I squared equals negative 1. So whenever you get an I squared, just write it as negative 1. Because we want to get an answer ultimately in the format a plus bi. We can't leave I squareds out there. So let's do these two cases here. I'm going to distribute this 3i to both these terms. So you get negative 15i plus 6i. Alright, so negative 15i plus 6i squared, excuse me, because I times I would be I squared. Well, 6i squared is the same thing as 6 times negative 1, which is going to be negative 6. So I have negative 15i minus 6. I'm going to rearrange that because I want the a term first. So it'll be negative 6 minus 15i. That's my answer there. For this one, I'm going to do FOIL. So first, 4 times negative 1 is going to be negative 4, and do outers. So 4 times negative 2i is negative 8i. Going to do inners, which is negative 3i. And then the lasts, which is going to be negative 6i squared. Again, that 6i squared is going to be negative 6 times negative 1, which will be positive 6. So negative 4 minus 8i minus 3i plus 6. Combining like terms here, negative 4 plus 6 is going to be 2. And then negative 8i minus 3i is negative 11i. So that's my answer. All right. It's a long enough video. Here's some examples. Pause the video. All right. Write the number using the imaginary unit I. So negative square root of negative 7, that just becomes the square root of negative 1 times square root of 7. So that's going to be I square root of 7. Can't reduce that. This one breaks up into square root of negative 1 times square root of 64. And 64 is going to be 8. And that's going to be I. So I times 8. We can write that as 8i. The last one, square root of negative 1 times square root of 12. Well, square root of 12 breaks down. Just see 2, 6, 2, and 3. Pair of 2's and a lone 3. Square root of 12 is 3 square root, oops, got that backwards. Is going to be 2 square root of 3 times I. In the right order to put that in, you put the number first, then the I, then the square root. That's the best looking way to do it. All right, more examples. Pause the video. Okay, I'm going to FOIL. So first is going to be negative 4 is positive 16. Outers is going to be positive 20i. Inners is going to be negative 20i. And lasts is going to be negative 25i squared. Okay, negative 25i squared is negative 25 times negative 1. So that's going to be positive 25. So we have 16 plus 20i minus 20i plus 25. Combine the 16 plus 25 is going to combine to 41. And the 20i minus 20i combines to 0, so plus 0i. So my answer is just 41. The next one, distribute the negative to both sides on the right. So negative 3 plus 6i, 1 plus 5i. I'm going to combine those. So 1 minus 3 is going to be negative 2. And 5i and plus 6i is plus 11i. That's my answer. That's it.